Okay, so today we move on from combinations into an application of combinations, and that is called expansion of binomials. So we are learning about expansion of binomials, which is an expansion of using combinations, and I'll show you how. So if you look at this expansion a plus b power 5, we can, just by looking at it, you know that we can write it as k naught a power 5 plus k1 a4b plus k2 a cube b square plus k3 a square b cube k4 ab4 and k5 b5. If you find it difficult to understand how that happens, I've taken a simpler example. Take the example of a plus b whole square, something you're very familiar with already. A plus b whole square can be written as a plus b times a plus b, right? Which is the same as a square plus 2ab plus b square. Here k naught is 1, k1 is 2 and k2 is 1. So if you were to write this, generally if you were to write this with k naught, k1 and k2, you'd write a plus b whole square is k naught a square plus k1 ab plus k2 b square. Now we're going to use the concepts that we have learned in combinations, and we're going to apply them here to come up with a general formula. Okay, so how do you obtain k naught? You can obtain k naught by not choosing b from any of the brackets. So don't choose b from any of the brackets, and you can only obtain k naught if you multiply a with a. And how many ways can you do that? One way. So that only occurs once. So k naught must be 1, because that will be the coefficient. If it occurred twice, then you'll have 2 at the front. If it occurred thrice, you'll have 3 at the front. And you'll have examples of when you have 2 or 3 at the front as well. But this is interesting. K1, what happens when you choose a from one bracket and multiply it with b from another bracket? How many ways can you do that? You choose a from one bracket and multiply it with b from another bracket. You can do it in 2 ways. You can either do it by multiplying this a with the b from the other bracket, or you can do it by multiplying the b from this bracket with an a from another bracket. There are 2 combinations that are possible. So that's why k1 would be 2. And finally we get to k2. Now how can you get b square? How many ways can you get b square? 1, only 1. You take b from this bracket and multiply it from b from another bracket. That is it. And you get k2 is equal to 1. Now this is pretty simple. This was the simplest example that I could come up with. Now I want to extend you a bit further into a plus b whole cube. So another example, a plus b whole cube. Now a plus b whole cube similarly can be written as k naught a cube plus k1 a square b plus k2 ab square and plus k3 b cube. We're going to use combinations to expand this again. K naught is equal to 1. Why? Because how many ways can you get a cube? How do you get a cube here? By multiply all the a's. How many ways are there for that? 1. So k1, k naught is 1. How can you get this term a square b? How many ways are there? 3 ways. You could do a times a and then multiply it with b from here, or you could do a times a and multiply it with b from here, or you could do a and then multiply it from b, multiply it with b from here. So if you have an a square term, then you have 3 brackets out of which you can only choose 2. So once you have the a square term, I've written it here, as once you have a square, there are 3 brackets which will supply b. You could choose b from this bracket, or this bracket. That gives you 3c1 ways. That means you have to choose b from one of these brackets. You already have the a square terms by multiplying 2 brackets. Now you have to make a selection of b from one of these brackets. That gives you 3c1 ways. If you move on to the next one, the ab square one, you'll see that you can get a from one of these brackets, and then how many ways can you get b from? How many ways can you get b from these brackets? let's say you picked A from this bracket, then how many ways can you get the B square term? 3 ways. You could do A multiplied with B and B, you get AB square, or you could take A from here and multiply the B and B from the first and the third bracket, or you could take A from you could take the second and the third one. You could take the first and the third one, or the first and the second one. And in all cases, you will end up with a AB square term. So the number of ways is that once you have selected an A, doesn't matter where you select it from, how many ways do you have to select the B in terms of combinations? Just B. Once you have selected an A, B square, sorry, B square. How many ways can you select B square? 3 ways, or if you write it in terms of combination, you're making the selection of B from 2 brackets out of how many brackets? 3C. So you're making the selection of 2 brackets from a number of 3 brackets. So you have 3 brackets and you're selecting 2. So 3C 2 ways. So you can obtain B square by multiplying 2 out of 3 brackets, that is 3C 2 ways. And finally, how would you get K3? How many ways can you get K3? 1. B times B times B is B cube. Just one way. So that is actually 3C 3 ways. You are selecting all 3 brackets from the 3 brackets that you already have. So 3C 3 ways. So if I compress this to a general formula, I can write it as A plus B whole cube is 3C0 A cube plus 3C1 A square B plus 3C2 AB square plus 3C3 B cube. Just notice the trend. Notice the trend here. You start from 3C0 and the numbers are going up till 3C3. 3C0, 3C1, 3C2, 3C3, and the number here is 3. So that gives you a trend. Yes, sir?
Wouldn't it be for B cubed, wouldn't it be 3C1?
For
the B cubed part?
No, it'll be 3C3 because you have 3 brackets and you're making a choice of all 3 brackets to multiply. The next one, if you notice the powers of one of the variables here, they go down from 3 to 0. So 3, 2, 1, 0. And if you look at the powers of B, you start off with 0 and you go to 3. So that's a really easy way of remembering it. When you're doing the combinations, let's say this was A plus B power 4, you would be doing 4C0 plus 4C1 plus 4C2 plus 4C3 plus 4C4. So those would be your coefficients. So actually by just looking at the binomial, you can actually tell me how many terms would be there. So if I said A plus B power 6, just by looking at it, how many terms are there in the expansion of the binomial? How many terms would be there in the expansion of the polynomial? 7. 60 plus 61, 62, 63, 64, 65, 66. 7 terms. And the terms would be 66C0, A power 6, B power 0. Then 6C1, A power 1, A power 5, B power 1, and so on and so forth until you get to 66. So the general formula here becomes A plus B power n can be written as A power n plus NC1 A power n minus 1 B power 1 plus NC2 A power n minus 2 B power 2, and you keep going on until you reach NCN A power 0 P power n. We'll be going through a few examples using this formula, which will make it really simple. Once you do a few problems, this should seem really easy. So I will make you go through at least 3 or 4 problems before we move on to the next topic. So don't worry for now. You'll be fine. Just need to make sure that you have this down. The rest of it is from Sadler, so you don't need to take it down. Let's just spend more time on the problem solving here. Okay, so what I'm going to do is I'm going to use the general formula. So what I'm going to do is I'm going to use the general formula to solve this question. A plus B power n is equal to A power n plus nc1 A power n minus 1 B power 1 plus nc2 A power n minus 2 B power 2, and this goes on to ncn A power n, A power 0, B power n. To make this simple, to make this really simple to understand, sorry guys for the spinning wheel of death. This is it's probably because of the number of windows that are open. I'm just going to stop the recording for a while. Okay, really sorry for what just happened. It's just my laptop's acting up. So first what we need to do is identify A. What's A here? What's B? Okay, if A is X and B is 2Y, let's expand it. We'll get X plus 2Y power 6 is the same as X power n plus NC1. So not X power n, sorry, X power 6, because n is 6. X power 6 plus 6C1 X to the power 5 and 2Y in bracket to the power 1 plus 6C2 X power 4 2Y power 2 plus 6C3 X power 4 2Y, sorry, X power 3, sorry, X power 3.
I don't see what we can do when you put it into that formula after that.
Just a second, 2 power Y power 3 plus 6C 4 X power 2 2Y power 4 plus 6C5 X power 1 2Y power 5 and finally 6C6 X power 0 2Y power 6. Done. Simple. Now, what do we do after this? The fun part starts now. Now, to solve this question further, first let's write the first term. We already know the first term. It's really simple. It's X power 6. The second term would be 6C1, which is 6 factorial over 5 factorial over 1 factorial. So it's just 6. So we'll have 6x5 times 2y. So 6 times 2 is 12. We learned that in primary school. 12x5y. Next one is 6c2. If you do this in your head, 6 factorial over 2 factorial over 4 factorial, which is 6 times 5 divided by 2, which is 15. 15, but then you have a 2y square term, so that's 15 times 4. Let me just check my calculations again. 6 factorial over 4 factorial, 6 times 5 divided by 2, which is 315. 15 times 4 is 60. Yes, 60 x4. Please let me know if I'm going wrong anywhere. Plus 63. 6 factorial divided by 3 factorial divided by 3 factorial, which gives me 6 times 5 times 4 divided by 6, which gives me 20. But then you have a 2 cube term here, which is 8. So 160 x cube y cube. Next one, 6c4 is the same as 6c2. 6 factorial over 4 factorial over 2 factorial. So whatever was 6c2 would be 64, which is what was it? 6 factorial over 4 factorial